Lexi, I forgot to record the 7-2 stuff, but Tyler's going to send you a picture of the paper. For slope fields, if I have a differential equation, dy over dx equals 8x plus 4. This is one of our like super simple differential equations that we do actually already know how to solve, because what we would do is we'd multiply by dx right here just to get it on the other side. So we'd have dy equals 8x plus 4 dx. And I would integrate both sides. So the integral of dy is just y, because there's like a 1 right there, so it's just going to be y. And then when I integrate 8x plus 4, I just use my power rule integral, and I'll get x squared. I'll divide by the 2, and I'll get 4 right there. I'll get plus 4x. Is that right? Thank you, Joshua. I, on purpose for real that time, did forget to put my plus c, so that I would make sure that you guys remembered. Now, what's happening with this is that is infinite solutions, right? Because there are like a gazillion ways that this could look, because we could have y equals 4x squared plus 4x, and c could just be 0, right? Or, copy and paste, this will be quicker, plus 1, or plus 2, or plus 3, or plus 4, or plus 5. I think you guys get the idea, right? And I could just fill this whole page up by just changing that c value. So there's an infinite number of solutions to these equations. So slope fields help us get a picture of possible solutions to differential equations. So I don't think that they will ask you to draw a slope field anymore on the exam. The reason for that is, like, up until last year, I would not have said, up until this year, I would not have said that. But from what I understand, your answer sheet that they give you for your free response is just blank space. It's going to say Part A, blank space, Part B, blank space. It will not have any copies of the graph. It will not have like a blank slope field for you to fill in. Because what they've done on some of the ones in the past is on the free response, there was a blank slope field like this and you had to draw it. I don't think you're going to see that anymore, because I don't think they'll be able to do that if they don't put a copy of the slope field on the answer sheet. So I don't think you will have to draw these by hand, but drawing a couple by hand helps you see the process, so that when you see a question like this that is multiple choice, or they might give you a picture of a slope field and ask you questions about it, then that will sort of help you. So what we do for a slope field is we basically just take every point on the graph and we plug it into our differential equation. So dy dx equals 2x plus 1. So I could make myself a table for all of these points here. So like if I start on the bottom left corner, that is the point negative 2, negative 2, right? And so that would be my x, that would be my y. And then dy dx is going to be 2 times x plus 1. So for this problem, it'd be 2 times negative 2 plus 1, which is going to give us negative 3. What does the derivative give us? Is the slope of our tangent line, right? So on a slope field, what you do is through that point right there, you draw a tiny little piece of a line that has a slope of negative 3. Now, you're guessing at it a little bit, right? Negative 3 would be pretty steep. What you kind of can think of, like is think of what like a slope of 1 would look like and either make it steeper or less steep than that. So I'm going to go like something like this for -3. Now, are there some other points that are also going to be -3? Have a slope of -3? There's several.
Like -2, 1, or -2, -1.
Right. Anything that starts with -2. So like -2, -1, -2, 0, -2, 1, -2, 2. All of those points have a slope of -3 because this particular differential equation does not depend on the y, right? There's no y in that formula. So they're all going to look like this. Those are all of those points sort of like on that vertical line. So all of them would have like the same slope. So we draw them all in with the same steepness. That's going to help us a little bit on this graph because since it doesn't depend on y, like everything's going to work like that. It's going to make it a little easier to draw this slope field versus some others that we see down the road. So then if I look at this next point, -1, -2, then that would be 2 times -1 plus 1. And that's going to give me -1. So now my slope is -1. So I'm going to draw a little piece of a line that has a slope of -1, which you can see that a little bit better because it'd be like going through those 2 points. So about like this. What's important there is that it cannot be, like it needs to be less steep than the line you just drew. You're not going to draw these perfectly here. And much like the one that we just did, all of those points that have all of those, doesn't matter what the y coordinate is, all of these are going to look about the same. And I'm not going to add those to my table just because we kind of know what that's going to look like. The next point is at 0, -2. So if I do 2 times 0 plus 1, I will get 1. So that's going to be a positive slope of 1. So that'll look like this. And that whole column right there will look the same. My next point is 1, -2. So that would be 2 times 1 plus 1, which will give me 3. So that needs to be a steeper slope. It should basically be the reflection of this part over here. So and then for that last point, I've got 2, -2, and that's 2 times 2 plus 1. For that, I'm going to get 5. That just, when they start getting up to like 5, 6, 7, 8, it's just like hard to even draw something that steep. Just try to make it look steeper than those lines that you just drew without being vertical. Like I said, I don't think you're going to have to draw one of these on a free response question anyway. When you used to have to draw them, they just graded relative to what you had. So, like, they weren't going to test to see if your line had a slope of 3 perfectly. It just needed to look steeper than the slope that was just 1.
So would that be like an upside down parabola?
It's not upside down. These are going to be like, these will be smiley face parabolas. So what you're kind of seeing here is like, well, the answer could kind of fit into, you know, the flow of the graph right there. So that gives you sort of a picture of what the graph will look like. I am pretty sure that Desmos does not do a slope field like in the normal thing, but I'm pretty sure if you search for Desmos slope field, the first thing it'll show up is a generator that will do a bigger picture much more quickly. Right, so like this is the slope field for 2x over x. If we want to do, let's type in what we just had, 2x plus 1. There is our graph. And the answers to these are parabolas. They're kind of skinny parabolas for that, but if we kind of zoom in there, that's what we're looking at. This is not the best example when you look at it on the big scale, because all these just basically look the same because they're so steep for that. But if we use like 0.5, you'll start to see it. You'll start to see it a little bit more, right? For that. So this is an example of what a slope field is. So for others, they may depend on x and on y. So if I'm looking at dy over dx equals x minus y, I would do the same thing that I was doing earlier. X, y, and dy, dx. So like for the point -2, 2, I would have -2 minus 2. Okay? And that would give me -4. So I got a super steep negative line right there. Oh, I'm sorry. No, you're not. It's me. I'm not doing well today. So that makes a big difference because that does not give us -4. What should we get? We should get 0. What does the line look like for 0? Horizontal line, right? So a little horizontal line right there. Now, these can take forever to do if you make the table for the whole thing. What numbers are going to have a slope of 0? When they're the same, right? So like -1, -1 is going to be 0. 0, 0 will be 0. 1, 1 will be 0. So sometimes you can kind of find patterns that help you fill it in a little bit more quickly. But you do eventually have to do all of the points on this graph. So then I would have, like, let's go to -2, -1. So that would be -2 minus -1, which is really like -2 plus 1, which gives me -1. So I'd have a slope of -1 right here. I'd have, let's go up right here, -2, 0. That'd be -2 minus 0, so I'll get -2 here. So a little steeper. -2, 1. What's that going to give us? -3. Again, you can kind of see a pattern happening here, like it's getting more steep. What do you think the next one's going to be before we even? -4 right there. And they start to get so steep you can barely tell the difference. So that takes care of just that line right there. You might be really good at doing this in your head. Somehow I always mess them up. I lose track. So if I'm really concerned with getting them right, I do the table. Like if this shows up on a test, I do the table. If I just want to be fast, I try to do it in my head. So like this next point right here would be -1, -2. That's going to be +1. So I'm going to have a positive slope right here. If I do 0, I'm sorry, -1, 0. That's going to give me -1. This one's going to be -2. You start to see like a pattern that's happening in each column here. It's like -1, 0. Oh, let me slide that down. I've got those in the wrong spot. See, I tell you, when I start trying to shortcut, I mess them up. I'm not great at doing this, and I'm off. I don't know, something's off. I didn't sleep good enough last night. I don't know. I'm not got it going on today. So it's -1, 0, 1, 2, 3, right? Or -1, -2, -3 is sort of what's happening. So like that pattern continues. So you can start to apply that pattern. Like right here, this is going to be 1. This will be 2. This will be -1. This will be -2. This will be 1. This will be 2, 3. This will be -1. This will be 1, 2, 3, 4. And if you're getting like really confused, you can make the chart for the whole thing. If it's a slope field this big, though, it just starts to take a pretty long time. So we will, on Monday, finish this up, look at doing this a little bit more. Look at the types of problems you're more likely to see, because like I said, you probably won't be asked to draw one by hand, but sometimes drawing one by hand helps you understand what's going on with that. So the only thing tomorrow is we will have our FRQ quiz, so make sure you've got that assignment.